So lesson 3 of the particle model. And this is about gases in particular, and about how the particles move in gases and how that relates to something that we call pressure. So we're going to start with this task, looking at the particle model, state and explain the compressibility of solids, liquids and gases. So what I'm going to do first of all is, there was a cartoon in the PowerPoint and I'm just going to copy that here. So what we notice is that in the solid, the particles are all in this regular arrangement, but they're very close together. Likewise, in the irregular arrangement of the liquid, the particles are still close together, but in the gas, they're far apart. And as we've already said in the previous lesson, they're moving randomly in all directions at different speeds. So compressibility means how easy it is to squeeze the material to put it into a smaller space. Well, if we look at the solids and liquids, what we can say is that the solids and liquids are incompressible. The in, remember, is the prefix that we use to say that something isn't not. So solids and liquids are not compressible. We can't make them go into a smaller space. Why is this? Because the particles are already close together. However, when we look at a gas, gases are compressible. Why? Because the particles are far apart. So there's lots of space between the particles, so if we can squeeze the gas to put the particles closer together, there's lots of space. In the next task then, we're moving on to look at gases in particular, and you need to complete the sentences, so pause the video and check your answers. So we have gas particles move very quickly. They don't all move at the same speed, so there are a range of speeds. Some are moving quicker than others, but they move very quickly and they move in random directions. So if a gas is put into a container like a balloon, the particles crash into the walls of the container. So there's a force. It's each of these little particles bashing against the wall of the container that puts a force. So there's the force of these collisions. This creates something called gas pressure. So in a balloon, when we blow into a balloon, we're putting in gas particles. They're moving around, colliding with the inside of the walls of the balloon. And that's what makes the balloon get bigger. It's that gas pressure, the force from those collisions, that causes the balloon to get bigger. Now, we're going to see how this relates to temperature. And to understand that, we need to remind ourselves what temperature is exactly, how it relates to the energy of the particles. So once again, pause the video to check your answers. And we can say that, remember, the temperature of a substance is related to the average kinetic energy of the particles. So if the particles have more kinetic energy on average, then the temperature is higher. That's what temperature means. So that also means then, if we increase the temperature of a gas, we increase the average kinetic energy of the particles, which means we increase the speed of the particles. So once again, pause the video to correct your pack. So the molecules are in constant random motion. There's a special name for this. It's called Brownian motion. And the temperature of a gas relates to the average kinetic energy of all of these particles. So once again, increasing the temperature will cause the particles to move faster. That's what it means, increasing the temperature. It means the particles are moving faster. If they're moving faster, that means they're going to have a greater force from their collisions on the walls of the container. And that will cause the container to expand, to get bigger, if it's something like a balloon, or to increase the pressure of the gas, if it was in something like a gas cylinder. Now, in the next task, you need to say why does a balloon get smaller as it is cooled? So we can think of this, to answer this, we can think of this in the other way first of all. Why does a balloon get larger when the temperature goes up? Well, this is what we said here. If the temperature increases, the average kinetic energy has increased, which means the average speed of the particles has increased. That means there's more force on the walls, of the inside walls of the balloon, and that will cause the balloon to expand because the gas pressure is increased. So we need to now think of the opposite. What happens if we cause the temperature to go down? So we're making the exact opposite argument for this particular question. Why does the balloon get smaller as it's cooled? So by cooled, we're saying that the temperature is going down. So as the temperature goes down, that means the average kinetic energy and therefore the average speed of the particles also decreases. That's what decreasing the temperature means. Since the average speed is decreased, this will decrease the force on the walls of the balloon coming from those collisions of the particles with the walls. Since the force is reduced, this means the gas pressure is decreased and hence the volume will decrease. The balloon will get smaller. Right, so these cases we were talking about a balloon, which is a container that can change its size. What happens if the container can't change its size? So in something like a gas cylinder, the container is made from heavy, thick walls of metal walls. So the container can't change its volume or not easily. What happens in that case? So if a gas is stored inside a steel container, how does it exert an outwards pressure? So the particles are moving about at high speeds and they collide with the walls of the container. These collisions mean that there is a force outwards on the container. So every time a particle comes along and collides against the wall of the container, it's going to act to try and move the container outwards. There's a force exerted on the container. Pressure is force per unit area. That's what pressure is. It's related to force. It's the force that happens in every unit area of the wall of the container. So that means that there is an outward force on the walls because there is an outward pressure on the walls because there is an outward force. Now, as we increase the temperature, that means the average kinetic energy and hence the speed of the particles is increased. That's what increasing the temperature means. So this means the particles are going to collide with the walls, A, more often, and also B, at higher speed. So temperature is low, the force is quite small, and they're not colliding very often. Particles are moving quickly. Now the force is much larger, and it's happening much more often. So this means they exert a greater force outwards, which means that the gas pressure increases. Okay, once you've corrected lesson 3, you need to make sure that you've completed the exam questions using both colour pens, black pen, closed book as if it was in an exam, blue pen for any additional answers you put in using all your resources and notes. And once you've done that, in green pen, you can correct the paper, mark what score you got.